Hi, my name is Rebecca Urena, and we are here on Behind the Buzz. Joining us today is William Ho from Incysus. Thank you for being here.
Hi, thanks for having me.
Of course. So let's talk a little bit more about the company and what you guys do exactly.
So Incysus is a cellular immunotherapy company, and we're trying to develop a therapy for cancer. And so ultimately, a couple of years ago, you may have heard of the chimeric antigen receptor T cells, the CAR T therapies, have been almost miraculous in the blood cancers. So the leukemias and the lymphomas, people like the University of Pennsylvania and Memorial Sloan Kettering showed that they could essentially create cures. Patients who've been given 3 weeks to live today, some of the longest ones, 13 years, they no longer have a cancer.
Wow.
Unfortunately for the solid tumors, the brain, the lung, the liver, they haven't worked so well. And so Incysus was formed to find a therapy to target solid tumors.
And what exactly is the timeline for that treatment?
In terms of development?
Yes.
So we were founded in 2016. Today we're early 2020. We have two FDA phase 1 studies that are active. And so we're now actively looking to enroll our first patients across 2 studies. One is in leukemia and lymphoma patients. That one will enroll at the University of Kansas with Dr. Joe McGurk is our principal investigator. And there we're actually looking to take cells from a donor to a patient. And so the advantage of that is that the donor cells, if they're young and healthy, are more likely to target and to eradicate the tumor. On the solid tumor side, that program is going to begin enrolling patients at the University of Alabama at Birmingham, and there we're targeting glioblastoma, a very aggressive brain tumor. Unfortunately, the mortality rate's about 100% for that.
Wow, okay. And so for the transplant of the cells, can anyone volunteer?
No, generally what we're doing is we're doing what's called a haplo donor. So haplo means generally a related individual, and almost everybody has a haplo donor. It's a first step. Ultimately, we'd like to get to a universal donor, or what they call off the shelf, but we want to ensure the patient's safety.
Of course.
And so a haplo donor generally means parent to child, child to parent, sometimes siblings and cousins who might be a match. Our goal, as I said, is to maintain safety. In the transplant setting, as everyone knows, when you transplant an organ into an individual, that your immune system will attack that organ. Unfortunately, for transplants, when I transplant a new immune system into you, the new immune system attacks you. Unfortunately, it's lethal.
Wow, okay. So that's great measures that you guys are taking. And what differentiates this company from any other same sector company?
Yeah, so I think what we've done, what we call drug-resistant immunotherapy, is really unique. In fact, we're the only ones out there who have tried it. And we actually just announced 2 weeks ago that we received issuance of a composition of matter patent from the US Patent Office, protecting our techniques and our approach. So what our approach is what we call drug-resistant immunotherapy. And the concept is to combine high doses of chemotherapy simultaneously with an immunotherapy that can remain functional. Now, for more than 80 years now, anyone who's diagnosed with a frontline solid tumor, whether it's lung, liver, brain, or others, get some combination of surgical resection, radiation, and chemotherapy. And it works because it shrinks the tumor. It buys you time, because any of us would actually rather a smaller tumor rather than a larger one.
Of course.
It's kind of intuitive. Unfortunately, chemotherapies work because they're like a bomb, right? So they're completely effective in killing, but they're completely indiscriminate. And one of the things that it kills is your own white blood cells. And unfortunately, even if I can shrink the tumor, if I eliminate all of your white blood cells, your body can't produce a response to fight off any of the residual tumor.
Right.
Unfortunately, those cells tend to be resistant to the chemotherapy. Now there's a lot of space, a lot of nutrients, the residual cells grow back very rapidly, and ultimately the patient succumbs to their cancer. And so our goal was to hijack the tumor's own resistance mechanism to the chemotherapy, genetically engineer it into these white blood cells so that they'll survive. We get power by using chemotherapy, radiation, and surgical resection to get rid of the vast bulk of the tumor. And the residual ones, we infuse these cells that are completely resistant to the chemo so that they can track down the stragglers and eliminate them.
That's great to know.
Thank you.
And lastly, why should investors that are just learning about the company really take a look?
We're on the cutting edge. Our goal is to eradicate cancer, eradicate tumors. In our animal models, we've shown long-term survival of the animals. When the tumors have been excised or the tissues have been excised, we don't see any tumors left. And unfortunately, we're the only ones who have taken this particular approach. And so we're leading the way, but also educating the investment community. And I think it's an exciting time. This is a novel approach that targets a mechanism that is conserved in all of our biology, and we think will ultimately lead to eradication of tumors.
Well, I hope so, and it does sound very exciting, all these things. Thank you so much for being here with us today.
Thank you for having me.
Of course.
Thank you.
I'm Rebecca, and this has been Behind the Buzz.